Hello and welcome to the last piece of this video series on Griscom and land use land cover change using MODIS and dynamic world imagery. So let's just so in the last video we had already completed all the analysis of Griscom and MODIS land cover change and evaluating carbon market tonnage for both Indonesia and Mozambique. The only thing we were really left with is being able to look at land cover categorization using this dynamic world dataset. So this dynamic world dataset was started in 2015 June and is currently a live dataset. It has 8 land cover categories: water, trees, grass, flooded vegetation, crops, shrub and scrub, built bare, snow and ice. So we are going to once again for between the years of 2016 and 2022 set our code up to be able to run and download the land cover categorization maps in our region of interest, and then be able to derive some summary statistics like the average within each of those categories, and eventually compare year on year if needed, or just really even just look at the most latest land cover as of 2022 and to see what the terrain looks like. This is very, very good because it's at a resolution of 10 meters. So that's a pretty good place to start. So what I have done already prior to this video is in futures utils now I've put in additionally an interface to be able to go and get from Google Earth Engine using the Gmap package the dynamic world data, as long as you specify a shapefile path, name for a region of interest, start date and end date within which it will generate an averaged image and zoom level, right? So we have the ability to go and generate this and then compute some zone statistics and put those into files in the output folder. I also kind of set it up to go ahead and generate all those files for Mozambique, Indonesia, Benakat, Subanjariji, and Martapura Forest for between the years 2016 and 2022. Uh, then I set up this dictionary to be able to change the column names for the classes that the files generate to based on the class table we just observed here, so that we get to observe something meaningful as an output. And finally, I set up this last piece of code so that we can go ahead and observe the land cover as long as we specify a year. How that would work is, for example, now we're looking at Mozambique for 2022. If I change it to 2021, it'll go to that file, pull it out, and kind of show me what percentages are within each of these land cover types for that region of interest in Reserva Recreativa. So with that set up, all we really then need to do is I just want to be able to bring all of these land cover categorizations onto a slide and then just leave it at that. Mostly these are just appendices. We only really go to it if it's needed. So I'm going to put this here. Mm, Maybe I will use a label like this here, since this was computed based on modis land cover 500-meter resolution. I'll just say so here, and similarly I'll go and make a tag here for Indonesia, and then I will just create a separate slide here to say that we're going to now look at uh, dynamic world 10-meter resolution, which is far more refined. And if we have a much more smaller polygon like we do in the case of Indonesia, probably want to consider this land cover analysis more seriously. But again, forests are not trees, and dynamic world only shows percentage trees. So there's limitation to dynamic world as well. Okay, so for now, for the slide on Mozambique, I'm just going to go here and put in screenshots of land cover classification from 2022. Right, so I'll just put 2022 there, And maybe I'll just put some of the other years as well, maybe the past 5 years. So I'll do 2022, 2021, just to see. 2021. Think of this as an appendix. It just has data. It's not great. 2021. Can put in 2020. And 19. And 2018. We don't need to look at 2016. It's okay. So we have 5 years of history now. That pretty much concludes our Mozambique analysis. Let's go in here and do the same here for Indonesia. I'll just call this the Nakat forest, and I will create a similar slide here for the other two forests. G forest and Martapura forest. In the process of creating these analyses just like that, you slowly start coming to understand the lay of the land in that region, the terrain, the names of the places, some of the problems regarding deforestation and how frequently the cycles are that go and reforest the place. So you start to understand things like that. That's the benefit of slowly actually doing the analysis and observing the changes as you go along. I guess this is only really to show how one would actually do this analysis step by step. Obviously, you can set up workflows to automate most of this for the future. Interesting here, just bringing in each of the past 5 years land cover analysis into the land cover percentages into the slides, and we're kind of done really. So eventually what we want to evaluate here is if we take the percentage of shrub and scrublands that we are trying to reforest, which is somewhere near 3% here, if you can see on these maps, and are basically 0.3% in 2022, and then multiplied by the total area. The amount of area that should manifest should be in total across the three forests equal to 16,000 hectares. That's what we're trying to study here, just to ensure that we have that much scrubland to reforest. So we'll do that as a shorthand calculation at the end. But for now, I'm just putting this in. Twenty 22. Okay. 2021. if you are observing the trends here, you can clearly see that between say 2019 and 2020, the amount of cropland significantly increased, the amount of shrubland also increased, and the amount of forest decreased. So clearly, forest has been deforested in favor of agriculture, and some has just been left deforested. So you can see the transitions that happen like such. Great. So we have all of this, and we just needed to do it for the last forest now. Let's start again with 2022. Sorry. Let's have it finish. Three. Some interesting. ID not found in access. Right. An error that said FID not found in access. So clearly, Martapura, when it generated, doesn't have FID but object ID. So maybe I'll ask it to get rid of that. I'll ask it to get rid of some other card. This is really just us browsing the polygons. Remember for the first two, for Supam Jariji and Benakat, we built our own polygons, simplified polygons, but here we're using the existing polygons. And that's what we're doing. It's also showing me all of this in scientific notation, and I don't really want it to do that. Just want me to display it properly, so I'm going to just tweak the number format a bit. Uh, Great. And the answer to doing that is just something like this. I'm going to remove the dollar sign there. And now I have as simple as that. Sometimes there is another field called shape length that I can remove here. Right. Actually, just from observing this, what I am observing is not great news. Like I see the shrubland level is really low as of 2022, so I'm afraid that some of these areas for reforestation already have been reforested. The whole purpose of this analysis to see whether what we think is reforestable already is reforestable or not. Yep, and with that we are done. And finally, here I just want to include the percentage of shrub and scrubland at 2022 for each, right? So I am, that is absolutely the last thing we want to do, which shrub or like shrub and scrub and 2022. And I want to show that for the knapsack it is, and for Anjarichi what it is, Marta Pura what it is, and total what the total hectarage was. So for Benakat we can see that it is 0.38%. For Subanjarichi it is 0.0668. Okay, let's go to 4 level 3817%, 0.0668%, and here it is unfortunately 0.000%, and we are going to times that by the total area of that region, which we know from here. So for Benakat it's that, for Spanjarichi it is that, and for Martapura it is that in hectares, and that is equal to 0 hectares in the last case. Let's compute that 0.3817. Is 34.15 hectares. And 4.42 hectares. It's not encouraging. We see here, we see that the shrub and scrublands total is only 38.57 hectares here. But again, I think we should lean on the high-risk data sets. I'm just concerned that there are no carbon credits there on offer if really the size of the reforestable area is so little. We need a certain minimum size for Vera projects. But I think with that, we are really done for this analysis. So, and we're done in this case as well. Maybe we should add a similar box here So we'll just say shrub and scrubland 2022 in this case is equal to 2.54% times the area of 175 kilo hectares, and that should be equal to that is what we have derived for Mozambique as well. I think great. That's all there is to this analysis. So just to revisit and recap what we have done for Griscom, we generated a map, we generated a raster layer histogram. From that, we derived weighted average biomass density estimate and compared carbon markets potential. Finally, from modus land cover, we derived the current land cover, percentage forest and deforestation over each of the last 20 years. We derived average deforestation rates, average annual, 10-year, 5-year, and we used biomass densities from Oak Ridge National Lab dataset and Global Forest Watch, and then considered a representative level for what we consider reforestable area and tonnage that we can get per hectare in order to derive total carbon market potential. And finally, we put in an appendix, which is dynamic over land covered at a 10-meter resolution, once again from Google Earth Engine. So that's what we have accomplished here for Mozambique and also for the three forested regions of Indonesia. So these slide decks look pretty ready to go, and they can be used for evaluation at the field level through field level studies. So with that, we come to the end of the series. Thank you for watching, and I hope you are able to perform similar analyses in the future. Thanks again.